Hello, Keith Rucker here at VintageMachinery.org. Guys, today I got a little quick project I want to get knocked out. This is actually for the museum, the Georgia Museum of Agriculture. They asked if I could help out with something that they need. And what they did is they brought me a part off of the steam locomotive. This is a tricock that is used to manually test the water level in the boiler. Now there is a sight glass on there that you can actually see the level of the water in the boiler. It moves up and down as the water level changes, and it's a really good, easy way to see what's going on. But there is a backup in case something happens to the sight glass. If it gets clogged up or it gets broken, you have to close off the valves where it doesn't work anymore. There's basically 3 little valves in the boiler at different heights, and you can crack that valve and look at the steam or water that comes out of that, and you can roughly determine the level of the water inside the boiler by using these tricocks. One of the 3 tricocks that is on the boiler on a locomotive had started leaking pretty bad, and basically there's a seat in the bottom of this valve that has to seat just right, and if it doesn't seat good, steam will bypass it. And it was just getting to the point where it was blowing steam pretty badly. So they asked me if I could dress the seat in this and actually true it up and freshen it up and get it back working again. This is, I believe, the original tricocks. These are made by Nathan Manufacturing Company. We're going to take this one here and try to reseat that. We're basically going to recut the valve and our valve seat, and then we'll lap it in place to get it worse, basically just like brand new. So that's today's project. Let me zoom you in here, show you what we got to do, and we'll get started on it. So this is the tricock that came out of there. Basically, it just screws right into the front of the boiler, and you have the live steam behind it. And again, when you open this valve, it just basically lets steam come out of this little port right here and out into the atmosphere. And you can look at that and see whether it's dry steam, wet steam, or just water coming out of there. And that'll, again, kind of lets you estimate the level of the water inside the boiler fairly accurately. Now, this has been kind of taken apart. It's just held together right now. I'm going to take the handle off the top. There's this piece here. This has just got some packing in it that keeps the steam from coming out the top, and then we unscrew this piece. I'm going to take the little spout out there. Once you kind of get in here, this is the part that seats down. You can see the little tapered piece, and that fits down inside of this into a seat down in the bottom. So when you tighten this in, this taper just matches up to a matching taper in the bottom that seats together and closes it. When you open the valve, it just lifts that up a little bit, lets the steam out this little side piece here. So there is a little place in there. What will typically happen with these is you get a little place that's just barely letting some steam get by, and then that steam will actually erode a little groove in there, and over time it just gets worse and worse and worse. So once you get just a little tiny amount of steam that passes, it will cut a groove, and it's a small groove, but it's enough. And that groove is actually right through here on this piece here. Now I know I measured it. This is a 60-degree angle. And so what we need to do is 2 things. I need to recut the seat down in the bottom of this, and it's just a little small area. I know you can't see down in there. And to do that, I've just got a countersink. I actually just bought this one. This is a 60-degree countersink, and we're just going to basically run that down in there, just barely touch it in there to freshen up, get a nice fresh piece. And I'll put this on the lathe, and we'll set the compound to 60 degrees. We'll get the matching angle there, and then we'll put this whole thing back together and lap them so they have a really nice seat in there. So my countersink is just barely long enough, I think, that I can grip the top there in the drill press, and I just got to barely touch that down in the bottom to clean that out. I think there's just enough sticking out there. I thought I was going to have to make a little extension to go on this to do this, but I think I got just enough to do it. So let's go over to the drill press. I'll see if I can grip that just enough. We'll probably just put this in a little vise And like I said, I just got to barely touch that in the bottom to clean it up so that we can have a nice seat down there. All right, we got our piece in the vise, and just looking at it, make sure it's kind of level there. I got my countersink in here, and like I said, I just want to barely touch down there. That should kind of center itself up when it hits the bottom. Shouldn't need much. Yeah, I'm just looking down in there to make sure I got a clean cut, and there actually is a little bit of a groove cut in the bottom, so I'm not quite deep enough. There's just one little place there that needs a little bit more. I need to get that cut out, and I am got clean brass all the way around in a circle now, so that bottom has been recut. So next I want to reface this area here. Gonna do it on the lathe. So let's I'm probably gonna have to chuck up on the front. I would rather have a little extra clearance there, but I'm gonna try chucking back here in the back. Let's see how straight this is. As much time, many times it's been turned and torqued, I'll be willing to bet you that we got some run out there. Let's see. Yeah. All right, we'll just grip it up closer to the bottom. I need to have a little bit of room for the tool to clear. Much better. All right, let me get my compound set to 60 degrees and we'll get that cut out. So I'll just loosen the little bolts here, nuts that tighten the compound down. Now this compound will tilt to whatever angle you want to cut, and I'm going to bring it around where I'm actually cutting back at an angle here. And I want that to be at 60 degrees. I'm just going to read down here on the graduated scale. I have to get a flashlight to see it. I'm going to set that on 30 degrees. Now this is a 60 degree included angle, so 30 degrees is half of that. So when I do 30 degrees here, we'll have 60 on the included angle. So that is the angle we need. Let me tighten this back down. Go ahead and put my cutter in here, and I need to reposition all this to cut this at the right angle. So we'll go ahead and just put it in there about like such. And now I can move this in and out to get that angle that I need. All right, we can come in here and touch off on that and just take a very light pass. You can see we're just barely cutting. I didn't quite clean up there, so I need to take just a little bit more. Just going to feed in a couple of thousandths, not much at all. I don't want to take any more metal off of this than I absolutely have to. I think we're cleaning up there now. Let's check that out. Yep, we're cleaned up all the way around. So that has that freshened up. So next step is going to be lapping, and to do that I'm using my Time Saver lapping compound. This is I got this two different kinds. The green kind is for doing hard metals like steel. The yellow stuff here is for doing softer metals like brass and bronze and aluminum and so forth. We'll use the stuff for the softer metals. And this is just a powder. It comes in different grits. I'm going to start with a medium grit. We've already got a pretty good surface in there to deal with. And I'm just going to take a little bit of this, and it doesn't take much. I'm going to put it over in a cup, and I'll take a little bit of oil. I'm just going to kind of mix this into a slurry. And then we will take that and just brush that slurry onto our part, and then we're going to lap it in. This is just an abrasive. This abrasive breaks down over time, but that right there will basically grind the two surfaces together so that we have a nice, perfectly matching surfaces. So if my angle is off even just slightly, a little bit of lapping will get a perfect match between the two. Now I'm just going to probably just chuck this up in a drill instead of doing it by hand. You can do this by hand, just put it in here and turning it by hand, but to speed things up, I'm going to put it in a drill, spin it around, and we'll go through the grits. So I'll start with this medium grit, then I'll go to a fine grit. Let's see, I started with medium, I'll go to fine, and then go to extra fine. So we'll do that, and we'll be back after we get this lapped in to get a nice perfect match in that valve seat. And you can kind of see that area there where the slurries are mating with one another. I'm going to put some fresh on there. And we'll do that. Usually you kind of see a little frosted kind of color in there once you've got a good lap, and then we'll go to the next grit. I'm reversing my drill. And I'm going to wipe that off. And you can kind of see that little frosted look in there. That's where it has lapped into the surface beneath it. I don't want to go too deep, so I think we're good here. I'm going to go to my next grit. I'll clean this out, and then we'll go down to the next grit until we get a nice finish in there. I took all that to my parts washer and cleaned it out. Now I'm going to my next grit here, and we'll just do the same thing. Put a little oil in there. I'm using whey oil here. You can use any kind of oil. The whey oil is kind of tacky, and it helps it kind of stick to the surface here. We're going to the next grit. I'm going to take that out. We'll put a little fresh on it. I think we're about got it where it needs to be. All right, I think that's probably good enough. I see that whole seat area making contact there. There's actually a little ridge on it where we've gotten down a little bit below the original surface. You can tell it has ground in, which is fine. And I'm going to take this over to the parts washer again, clean it up real good, get all that grit out of there. And I think we can put this back together. I've already been through the other grits off camera. And I think we're ready to put this all back together. So let's see, this valve stem screws up into this top piece here. And again, that screws in and out. So when this is going to stay stationary, so when you turn the handle, you can see that moves the valve or the seat there up and down. So that's kind of how that works. This, in turn, tightens up here. And let me get this in the vise. We'll get that good and tight. Grip that there. All right, we'll tighten that up good and tight. That's going to have steam pressure on it, so we want that to be good and tight in there. This is our packing gland. There's packing up in here. This tightens down, and that packing compresses up against the stem and keeps it from leaking. So we're just going to leave the packing that's in there in it. I think it'll be fine. I'm going to get that good and tight so that packing will seat up against that stem. All right. And put the handle on top. There's a nut that holds it in place. And we'll tighten that nut up. All right. So now we can turn the valve and seat that down in the bottom. And the last little thing to do is put that little spout back on. And that just screws in. There we go. One Nathan tricock all back together. And this is ready to go back on the locomotive. Well, that is all back together, and like I said, ready to go back onto the locomotive. I think what we'll do is go on a little field trip here. After a while, be a little bit of time later this morning, but you guys won't see the difference. But we'll go out to the museum and actually install this back onto the locomotive, so you can kind of see exactly where it goes and how it's used in the actual application. So we'll get that done here in just a little bit, and then that'll probably wrap this up. So here we are looking at the tricock installed. It's the one here on the top that we redid, and you can see the other two in here. These are all just installed on the front of the boiler, and again, you can use that to kind of determine the water, the height of the water in there. So we got a sight glass over here, and I don't know if you can see it or not, but the water level is right there. So that just kind of gives you a nice indication. You can see the water level will go up and down as the water level in the boiler goes up and down. So as you use the water, it goes down, then you use an injector, water level will come back up, you put water back in the boiler, and then it'll go back down, and that keeps track of it. But I think, like I mentioned before, this is glass. Sometimes that glass may break if something hits it, or sometimes it'll just get thinner and thinner and thinner, and it can just bust out. If it does, you can close these two valves and they'll shut the steam off to it, but then you still need a way to check the level of the water in the boiler, and you can use the tricocks over here, and you just basically you open these valves up, and you can look at what's coming out. If it's dry steam, kind of a wet saturated steam, or just water coming out at the different levels, you can estimate what your water level is, and that's how you can keep track of it. When running a boiler, it's very, very important that you keep your water level above the crown sheet in the boiler. There's the firebox is down here on the bottom, and there's a sheet that goes all the way around here that the fire's in there. It's open, and then the water is covering it up, and you don't ever want your crown sheet to become exposed. The water level get below the crown sheet, or it can get super hot, and that can lead to a boiler explosion. But anyway, the tricocks, there we are. We're installed, and this is on our 1917 Vulcan Iron Works steam locomotive, a little narrow gauge locomotive out here at the Georgia Museum of Agriculture. All right, there you go. So there you go, guys. A little quick project in the shop today, refacing the seat on that tricock valve. Pretty common thing that we have to do at the museum from time to time on these steam valves is to reface those seats. They will, over time, like I mentioned before, kind of erode out, get corroded, whatever, start leaking. And instead of having to go buy a new valve, we can often fix the valve that's there. And quite honestly, these older valves that we have are so much better quality than the newer valves that you buy today, that we try to use the old ones as much as possible. And in the case of that tricock, I'm pretty sure that's original to that locomotive, so we definitely want to try to keep it in place. You can order new ones, but they're not near as pretty, they're not near as beefy and heavy, and they just they don't look right. So, you know, we try to keep the stuff as original as possible. So with that, guys, we're going to sign off here. We'll get out of here, and appreciate you guys coming along for the ride. As always, thanks so much for watching. Please, please, please leave those comments down below. It really helps out with the algorithms on YouTube. Hit that like button. Again, it really helps out with the algorithms on YouTube. And a big, huge thank you, as always, to those who support the site financially through Patreon and PayPal. It really enables me to take the time to shoot these videos, do all the editing and everything else that goes along with it that you don't see behind the scenes. It takes a tremendous amount of time that I could be out here working in the shop and making money otherwise. So that really helps out a lot. And thank you for those that do it. There are links down in the description for being able to contribute, but either through Patreon or PayPal. Both of those work out really good. And thank you guys that do that. And with that, we are going to sign off. We'll get out of here. We'll catch you on the next video. Again, thanks for watching.